I think we'll make a start. Firstly, a very warm welcome to all of you. Those who may not know me, my name is Jeyakumar Henry, and it's an absolute delight to have today with us Professor Gurr, who's come all the way from Reading in the UK. And I also want to make a special thank to you, Mike, for coming here today, because he's in Singapore to visit his family and not to do shenanigans like this, but I hijacked him with great delight to have him here. Before I formally introduce Mike, I want to make two comments about the event today. So Mike is going to talk about his life in science, and instead of having a talk that you're normally familiar with, what I thought we'd do was to have a tete-a-tete with Mike, sharing with us his life journey and his scientific endeavors, so that we get a very wonderful cosmic view of his science and his perspective of what is science all about. So without stealing his thunder, because Mike is going to talk about his life, I just want to give you a brief background in that Mike is an internationally recognized lipid chemist and a nutritionist, and for those who don't know, has published a monumental textbook, which I hope will be a wonderful Chinese New Year gift if you haven't bought one. It's a fantastic read, it's highly readable, it's not only readable but also highly erudite, so we'll flash up some information about that in a minute. So by way of introduction, Mike did his first degree in chemistry from the University of Birmingham, and then he followed it up with a PhD in biochemistry from the same university, which he finished in 1964. And then from there, he went to Harvard University, where he had 2 wonderful years of research exposure and experience. And then from there, he moved, I think, one of the early scientists who moved from what we call academic research to industrial research, having worked in Unilever for almost 22 years, from 67 to 78. And then from there, he had some seminal contributions to make in the Dairy Council between 1979 and 1986. And then from there, he moved on to the Milk Marketing Board from 1986 to 1990. And I believe from 1990, he, inverted commas, retired to the Scilly Islands. Scilly Islands is not silly, it's a wonderful place, which he's going to share a few slides of. So with those brief introductions, it's an absolute delight to have Mike. Thank you again for coming. Mike,
Thank you for inviting me.
Pleasure. Mike, I'd like to start by taking you perhaps way back into your childhood and reflecting on a little bit about where you lived in your early childhood and what formative influences your teachers or the environment had to decide to do a prosecution in science.
Working? Okay. Yes, well, I was born in the south of England in 1939, several months before the outbreak of the Second World War. My first year in school was a year before the war ended. And then in the UK at that time, food rationing carried on for at least 7 years after the end of the war. So it was a pretty Spartan childhood, but nevertheless quite interesting. During the time when I was at school, I started to have 2 main interests in life. One was in music, that was the first one. I knew perfectly well why I was interested in it. I mean, it just happened. I was naturally interested in music. And my parents had a piano, which I started to learn to play at the age of 6. The other great interest at that time, when I went to secondary school, which was 1950, was in chemistry. Now, don't ask me why I got interested in chemistry, because the teaching was pretty poor, my recollection is. But I was passionately interested in chemistry. So when it came to deciding on going to do further education at a university, I had two choices. I could go into music or I could go into science. My music teacher wanted me to go to the Royal Academy of Music in London, but I chose to study chemistry because I knew deep down that I wasn't talented enough to be a professional musician. But as a scientist, I had a wider range of opportunities, and I could pursue my interest in music as a hobby.
And I presume you still continue your interest in music. Do you play with your piano, or
Yes, I do. My parents brought me a grand piano for my 12th birthday.
Wow, what a grand present!
And now that I'm retired, I have more time to play it.
Great. And what's your favorite conductor, or sorry, not conductor, composer?
Franz Schubert.
Great. Good. So let's move from your time at school, and any reflection on why you chose to go to Birmingham?
Not really. I applied to the prestigious universities of Oxford and Cambridge, and they didn't want me. Birmingham offered me a place immediately. But of course, Birmingham was an extremely good centre for chemistry, so I did well.
Absolutely. And if I recall, you did have a couple of Nobel Prize winners from that institution, didn't you?
Yes, Franklin was one in carbohydrate chemistry, and I can't remember it. My memory doesn't extend.
Good. Okay. So let's move on from your time in Birmingham, where you did your bachelor's and your PhD. And I think at that time the intersection between chemistry and biochemistry was much looser. So you could probably comfortably move from chemistry to biochemistry. Tell us a bit about what you did during your PhD program.
Right. My PhD program was with a man called Tim Hawthorne, who at that time was a university lecturer, became a professor later on. Hawthorne was, I should say, a world expert in phospholipid metabolism, especially the phosphoinositides, which he always felt were going to be very important. He had a hunch that they would be. You must remember that at that time, we're now talking 1960, lipid biochemistry was really not pursued by many people. There were only quite a few of us doing lipid metabolism at that time. So we had the world to ourselves. And Hawthorne gave me, my initial project was to study the phospholipids of the liver cell nucleus. Nobody had done that before. And the techniques of chromatography were becoming quite widely used, so I was able to map out the lipids in liver cell nuclear membrane. So that was, it wasn't world-beating stuff, but at least it was something slightly new. And the other project was really much more nutritional, because the head of department, Professor Alistair Fraser, who was a world expert on fat absorption, he was the first one to demonstrate some of the mechanisms of how triacylglycerols are broken down in the gut. And he later became, he was a medic and a biochemist, and also a nutritionist. And he later he founded and became the head of the British Nutrition Foundation. So that was my, I suppose, first interest in nutrition. And what we wanted to do nutritionally was to study the turnover of phospholipids during the process of fat absorption. Now, turnover, at that time, lipids were thought to be terribly inert substances that didn't change very much. We now know that they are turning over completely all the time. So there's a process of anabolism and catabolism going on at the same time, which is biochemically favorable for the control of metabolism. Okay. And so what we did was to, what I did, was to give a dose of my control animals were given a dose of glucose. These were rats by stomach tube, and the fat-absorbing animals were given a dose of olive oil, and simultaneously an intraperitoneal injection of inorganic 32 phosphorus, labeled phosphorus. Can you all hear me? Yeah? Okay. And so I dosed the animals and injected the isotope. And then subsequently, after a period of time, and I can't remember how long it was, we extracted the lipids from the gut enterocytes, duodenal enterocytes. Extracted the lipids, separated the phospholipids by two-dimensional paper chromatography, and that I put on a film which had to be exposed for several hours. So during that time, I went and had a meal in the Students' Union. And when I came back, I went into the darkroom and I developed my film. Now, I really didn't know what I had to expect. And I call it it's not, in the great scheme of things, it's not terribly exciting, but for me, at the time, it was my eureka moment. It was the moment when science suddenly became really quite exciting. And I exposed the film to my control animals who had glucose. There was some labeling in the phospholipids, but not very, very little. And on the animals that became the fat, there was one big labeled compound, which was the phospholipid phosphatidylcholine. And we interpreted that as the fat was being absorbed, it's going into the lymphatic system, and then finally into the bloodstream as chylomicrons, lipoproteins which carry fat in the lymph system and the blood. And the chylomicrons are stabilized by a membrane which is predominantly phosphatidylcholine. So what we were observing was a huge turnover in phosphatidylcholine and a synthesis to provide the stability of the chylomicron membrane.
Wonderful, because I think your story is very important because your observation has stood the test of time. And in a sense, that's a very seminal piece of work that you did. So I'm now going to move you from your time in Birmingham to where you spent 2 productive years in Harvard. And I think it's a nice story for us to hear from you, Mike.
Yeah. It was productive only in the sense that later on, the repercussions of the work I did there became apparent. In terms of publications, it was 2 years really of not very much happening. It started because before I left Birmingham, my supervisor, Tim Hawthorne, went to a meeting in Oxford of the Biochemical Society, and he found himself co-chairing the meeting with Conrad Bloch, who later won the Nobel Prize for his work on the biosynthesis of cholesterol. And Tim relates to me that during a particularly dreary lecture, he and Conrad started conversing sotto voce, and Tim said, I've got what I think is a promising student who would like to work in your lab. Could you take him? And he said, well, yes, not this year, but next year. So I spent an extra year in Birmingham waiting to do. So, yes, I arrived in Harvard University in 1964, in September 1964. And the blood laboratory at that time had two main lines of work. One was the biochemical pathways for the metabolism of steroids. This was work carrying on from the Nobel Prize winning work on cholesterol. And the other group were studying the biosynthesis of polyunsaturated fatty acids. And I was allocated to the polyunsaturated fatty acid team. And I was given what appeared to be a very interesting project. So I need to spend some time describing this in detail, because although at the time it was not terribly, apparently very productive, later on it became quite significant. The team who was studying polyunsaturated fatty acids made great use of a lovely little organism called Euglena gracilis. Now, Euglena gracilis is essentially a monocellular alga. And it swims about, it has a tail, yeah. But it is very, very unusual in the sense that it can behave not only as a green plant, but as an animal. Now, I better explain exactly how we know that. If you give Euglena a completely mineral diet and full exposure to light, it will behave as a plant. It has chloroplast, it has typical plant membrane lipids, which are not predominantly phospholipids, they're galactolipids. Galactose is the term. If you, on the other hand, shut it off from the light, put it in the dark, and give it a diet of glucose or some sugar of that sort, it changes its composition completely. It behaves as an animal. Its membrane lipids are mainly phospholipids. Now, there's a very significant difference in the fatty acid composition of the galactolipids in the plant form and the phospholipids in the animal form. And that is, in the plant form, the structure of the main polyunsaturated fatty acids, they're mainly 16 carbon atoms in chain length, and they're mainly what we call the N-3 structure, or as the Americans still like to say, omega-3. So the omega-3 fatty acids. In the phospholipids in the animal form, they are mainly 18 carbon fatty acids of the linoleic acid family, N-6. So my project was to study the biochemical pathway towards the formation of a 16 carbon chain length polyunsaturated fatty acid N-3 with double bonds 7, 4, 7, 10, 30 along the chain. Now we knew that if we analysed the fatty acids in light-grown Euglena, they would contain the monoaminoic acid with double bond in the 7 position, dianoic acid 710, trianoic acid 710-13, and the one with four fatty acids, which was the one we're interested in. So it seemed a no-brainer that we should synthesize the monoaminoic acid with the 7 double bond, which I did in the lab, and I took my compound over to, well, I made the acetylenic equivalent, and I got on the subway to Boston, to New England Nuclear Corporation, and they tritiated it for me, and I came back, and we fed our tritiated fatty acid to Euglena grown in the light, with a minimum kneading, and we expected to see labelling in all the compounds that I've named. It wasn't so. To our utter surprise, there was no labelling in the plant-type fatty acids. They were all in the animal-type fatty acids. In the 18 carbon series of N-6. So Conrad said, well, yeah, something's gone wrong here. You better try it again. So I tried it again, and we repeated. I don't know how many times we repeated, always. In the end, he said, well, I think, right, we'll go on to something else. I've obviously given you a very tough problem, and I'm very sorry that it's turned out to have a negative result. And I said to myself, well, hang on a minute, I don't think there is such a thing as a negative result. Either I had done the experiment incorrectly and made some errors, introduced some glucose into my medium or whatever, or the original hypothesis was wrong. And so I sat and thought about it for days. Now I knew that it had been established in Conrad's lab that the substrates for most of the fatty acids, certainly the monounsaturated fatty acids, the conversion of palmitic acid into the monounsaturated fatty acid, the substrate was an acyl carrier protein derivative. So that's a thiol ester, not an oxygen ester. So my proposition was that in order to be desaturated, the substrate, my labeled substrate, ought to be incorporated into a galactolipid, and it wasn't for some reason. And I suggested to Conrad that that we should think about the possibility that desaturation occurred not on acyl carrier protein fatty acid, but as oxygen as on a phospholipid or a galactolipid. And he said, "Oh no, I don't think that's a go. We'll try something else." So I was sort of disappointed that a very talented Nobel Prize winner should have such a limited way of thinking.
Maybe that's why he got the Nobel Prize.
I don't know. I can't criticize. He was a very kind man, and he was very good to me. So I said, well, I'll put that aside and hopefully do something with it later on.
Great story. I now want to take you back from Harvard to the Unilever Research Center. For those who don't know about the research center in Colbert House, if I recall, in the good old days, it was one of the largest research centers, am I right?
It was the largest food research lab in Europe, but
certainly
I don't know about world terms.
Yeah. And so I think, Mike, I'd like to hear a bit more about how, in this day and age, where we talk about applied science and sort of fundamental research, how you moved from a fundamental research paradigm to Colbert House, and you obviously had the great fortune to work with Tony James,
Yeah.
Who, as many of you know, was the co-inventor of the gas chromatography. So Mike has been rubbing shoulders with some of the incredible people of science and discovery. So two things: how did you make the transition, Mike, and how was it working with Tony?
Yes, how did I make the transition? Well, I did have a year in the Netherlands between going to, between leaving Harvard and going to Unilever. And the reason I went to the Netherlands was because there was a very good group there studying membrane lipids, and they had a wonderful team of synthetic organic chemists, and I wanted to learn more about synthetic organic chemistry because I figured that a biochemist needed to have such techniques behind him to make substrates for enzymic reactions. Okay, so during the period between coming back from America and going to Unilever, I went on a number of interviews for various jobs. I had a couple of academic interviews which didn't turn out. And I knew that Tony Gaines' lab was doing work that I would like to do, and I got an interview with him, and he said, well, after you finish in the Netherlands, you're welcome to come to my laboratory. So that was how it happened. I didn't know him before that, so that was my first meeting with him. So I went there in 1967, and lo and behold, Tony had a group who was studying membrane lipids, not in Euglena, but in Chlorella vulgaris, which is a much simpler single-celled organism which doesn't flip between animals and plants. You know it's always going to have chloroplasts, and it's a very much simpler organism. So we worked on Chlorella vulgaris, and I discovered that my colleagues in the lab had already made some progress towards demonstrating that the real substrates for fatty acid desaturation, certainly in chlorella, were on the galactolipids. And so this fitted in nicely with the hypothesis that I proposed to Conrad Watt. And so that's what we did. And we studied biosynthesis of linoleic acid in chlorella, and demonstrated, at least to my satisfaction, that it took place as the substrate was phosphatidylcholine. Are you speaking too near the microphone? Okay, so we published that. I went to a meeting in America shortly after we published, and Conrad still didn't believe that this was, he didn't think I'd proved my point. But then a couple of years later, he published the fact that phospholipids in a yeast of some kind, Candida utilis, I think, would make polyunsaturated fatty acid via this lipid pathway, and various other people. I mean, it's now a well-known mechanism. So
Wonderful. Mike, I want to help share the story with how you met up with Nancy Rothwell and talk through the fantastic study you did on pigs, which there's a connection between your study and my own supervisor, Professor Philip Payne from the London School of Hygiene, with Derek Miller, who had published in 1961-62 this fabulous study of feeding a group of pigs a very low protein diet, very large amounts, and showed demonstrably that they did not get fat because of what we now call diet-induced thermogenesis. So the DIT story has been around about 60-50 years, and now we see a renaissance. I wanted to share with us, Mike, the study you did with Nancy, which was a very elegant study, which I recall you published in the Journal of Nutrition.
Yes, it was. if I could lead into that, I won't go straight onto that because one thing I did discover, when I went to the Tony Gaines group at Colworth House, Tony had previously been at the Medical Research Council Institute, National Institute of Medical Research in London. Okay. And that's where he had invented gas chromatography. Now gas chromatography, of course, was a godsend because he had all the companies, oil companies and food companies coming to him and asking him to analyze their samples on the GC. Okay. And Unilever was one such company, and they offered him unbelievable facilities at Colworth House and a salary twice what he was getting with the Medical Research Council. And so he said to me, well, it was a no-brainer. I couldn't refuse. And so for the first few years that I was there, we were doing research which was very academic. We might as well have been in a university. But one had the feeling this can't last, and in fact it didn't. The company hit, or the country hit hard economic times. And Tony called me into his office one day and said, Mike, I think it's about time you had a career change. So immediately, this is the difference between working in industry and a university. In industry, okay, you're told to do that, you do that, or you go. Okay. He said, I think you should go into nutrition. We're a major worldwide food company and we need more expertise in nutrition. And I was, although I had no choice in the path I took, I did have some choice in the project that I decided to adopt. And I wrote a paper for the management in which I prophesied that a big problem facing the community in the future would be obesity. I'm not quite sure what led me to that conclusion, but I was sure that was going to be the case. And look what's happened. So I said, I think we ought to be doing a project on obesity. And to cut a long story short, we decided at the time, there was a going theory originating, I think, from Hirsch in America, in New York, that overfeeding babies at a certain critical period in infancy would lead to more fat cells and therefore obesity. Well, it doesn't actually follow. And so we decided to start on that. And in collaboration, we did animal model studies at Colworth and human studies in collaboration with scientists in Cambridge. Both animal and human studies led us to believe that this hypothesis was really not worth the paper it was written on. We were studying essentially the end product of overeating, shall we say, and we thought that energy expenditure would be a much better way to take. So we're lucky that Colworth House had superb calorimetry facility, I got in collaboration with a man called Mike Stock in the University of London, who unfortunately died a few years ago.
Who was Nancy's supervisor?
And he introduced me to this very charming young lady,
I agree.
Nancy Rothwell, who had a first-class degree, and he said, well, let's jointly supervise it on a PhD project. And so in London, she spent part of the time in Prof House, part of the time in London, and in London she and Mike Stock were studying brown adipose tissue in rats, leading to their very interesting work on diet-induced thermogenesis. At Colworth House, we decided to follow up the Derek Miller experiment, which you mentioned. Now, Derek Miller's experiment was a lovely experiment, but with only an N of 2, which didn't give much scope for the statisticians. So we decided, with Derek's full approval, that we would, Nancy would study this phenomenon in pigs, and indeed we showed that pigs, by manipulating their diet, and mainly the protein content of the diet, waste energy like mad and produce enormous amount of heat. That was really the story of how we got involved with Nancy.
Fascinating. So I'm aware of the time, so what I'm going to try and do now is to take a pause from pursuing questions with you, Mike, and open the floor to questions from the audience. So the floor is yours. So I think the space is quite small, so you can be voluble with Dr. Mike. Right on? Any questions?
No, I only wanted to add that in addition to his book, The Lipids, I remember the Lipid Biochemistry that he wrote, along with Keith Frayne and some other people.
Yes, that's the same book, yes. But it's called Lipids now, with the biochemistry is in small.
Yes, that all started...
So it's Lipid Biochemistry, it's not lipids.
Hmm?
So I remember that book.
Yes, it was called Lipid Biochemistry and Introduction.
Yeah,
and
exactly.
It happened that one day in, I think, about 1969 or thereabout, Tony operated the open lab system. We weren't in offices, it was completely open lab. And one day, he hovered behind me as I sat at my desk and said, Mike, I want to ask you a favor. I have been asked to write an introductory student textbook on lipid biochemistry, which wasn't available at that time. Would you consider being co-author? And I was absolutely astounded because I was a young member of the team, and there were people in the lab who were much more able to do it than I was. But anyway, so I said yes, of course, and we worked on it, and we produced the first edition in 1971. So the one that was on the screen earlier, this one that is shown is edition number 6. But biochemistry, and particularly lipid biochemistry, has changed out of all recognition in that time, and it's not the same subject as it was. So we had to completely rewrite the book, and it's entirely different from the original. But I hope it's...
Yes.
Sorry, any phospholipids that are beneficial for the brain, for cognitive function?
Sorry, I didn't.
Any phospholipids beneficial for the brain for cognitive function? Any phospholipids that you can recommend for brain function and cognition?
Well, as a dietary component, I think the honest answer to that is no. That takes me out of my zone of expertise, I think.
Yes.
I need to think about that.
Mike, I'm not a scientist, so all the, it's fascinating to listen to your life story, but I am from a chef training school. Can you translate to something so simple that I can take back to the school? Maybe 2 things. One, because eating is an occupational hazard in our school. The chefs are all getting better, and and we organize a culinary conference, nutrition conference once a year, and I would like you to advise us. There are 2 things that you will advise the chefs and advise our students. What would be?
Yes. I mean, my own thoughts about nutritional control of weight, I mean, I wouldn't go for any particular diet. I think that the best policy is to eat. I don't think there are any foods that I would say you shouldn't eat, or you should eat, but to have as wide a range of foods as possible, and not to eat too much of any of them.
So everything in moderation is your motto?
Yes, but of course everybody is different, and I think diet-induced thermogenesis differs in different people. So I think I'm particularly prone to it, because if I have a large meal in the evening, I know darn well that about 5 hours later I'm going to be very, very hot in the middle of the night. And I think that's one of the reasons why I've managed to keep my weight for most of my adult life at 60 kilos. I've only deviated from 60 on a couple of occasions. I did go up in weight, and I know why that was, because I walked and had less exercise, and I ate more business lunches. But everybody is different, so I'm always hesitant about giving general advice, because it has to be tailored to the individual. But I think eat as wide a range of foods as possible, and not too much of any of them.
Yes.
What is your view on coconut oil?
Coconut oil.
From a nutritional point of view.
Yeah, I mean, the characteristic of coconut oil is the large concentration of medium and short-chain fatty acids. And I think the evidence is that they are metabolized differently and have less energy value per unit weight. So yes, I mean, I would recommend any of these oils with medium chain fatty acids. Yeah.
Is it good for the brain?
I've no idea. I should say to you that I'm in no way a neuroscientist.
So you seem to have an interest in the brain.
Yes.
Okay. Okay, good. I'm just treating the audience for any other questions, or whilst they are reflecting. Mike, I'm going to ask you a more philosophical question, which is, do you think serendipity plays an important role in scientific discovery?
There's a general feeling in the non-scientific population, I think, that science is not a creative activity, and I think that's absolutely wrong. It's very much a creative, and therefore one can be inspired by all sorts of things and have an idea, and then you follow it. Yes, so I think, yes, it does play some role.
And the complementary question is something actually which came up yesterday when we had this talk with these 3 Nobel Prize winners, is the importance of working, as you've rightly pointed out, with people that are bright and smart, and in laboratories that are bright and smart, because in a sense, it's a very cyclical process of intellectual discourse. And if there's any advice you'd like to give our younger scientists in terms of future directions for making some impact with science, what recommendation would you give, Mike? It's a loaded question, but I'd like your response.
Yeah, can you say it? I mean, I'm not quite clear what you're asking me to do.
So, I mean, the nature of science now is so different to what you were at the time when you had these wonderful opportunities and so on and so forth. So if you were starting all over again in science as a fresh graduate, what kind of things would you be looking at to enhance the intellectual ability of your science, but also to become creative? What are the sort of factors that actually drive these things?
I mean, one of the ways in which science has changed over the years, much for the better, I think, is that there's much less rigidity between disciplines. So we used to talk about biochemistry and chemistry and physics, and now I don't think any of those barriers really exist. So everything has come together. So my advice would be to study as many, be proficient in as many different disciplines that you think are likely to be useful to your future aspirations in science, and keep your general knowledge.
Great. Any more questions from the floor? Yes.
Just a question about the protein in diet-induced thermogenesis. Are you saying that there's a way that diet can be tailored in possibly, say, humans, for example, to induce this more so than, say, the alternative, which is just fat retention, I guess?
Yeah. Unfortunately, my studies really ended at the animal models stage with the pig work, and I never then after that got involved in any human studies, and maybe Jay knows more about that than I would. I mean, with people like Philip Payne and
Yeah.
did you?
So the short answer is that the translation of the animal studies to humans will be rather poor. Even if you put yourself on a very, very low protein diet, the stoichiometry of increasing DIT is not as profound as you see in the pig. So the short answer is it ain't the same in humans. And as Mike has pointed out, there's incredible variability between DIT in all of us. So the renaissance of interest in DIT now is a bit different, is to see whether some of your white and gray adipose tissue can become brown. And that's just kind of happening. I'm very skeptical about the BAT story, to be blunt with you, but that's my personal view. But it's a holy grail that everybody's pursuing, and hallelujah. Yes?
So, what's your view on understanding the gut microbiome? Usually gut microbiome, and designing and tailoring the diet based on the gut microbiome, the gut health. How do you think?
Okay, so the question is that what's your view about altering your gut microbiome using diet, and what's the link between microbiome and health in overall?
Incredibly important, I think. I mean, there are, I don't know how many trillion more cells, microorganisms in the gut than the whole of the rest of our cells put together. And I think in recent years we're learning more and more about how this might affect us. I mean, I have to come clean and say, I don't know whether Jay mentioned it at the beginning, that I retired in 2000. And I haven't really, apart from this book, which I completed, I only wrote one chapter of the latest lipids book. So I'm really out of touch now.
But I think Mike is being very modest. He still remains a very sharp scientist, and I can tell you an anecdote that happened this weekend when I met him and his wife, is that he tried to reflect when I first met him. And I said to Mike, I think I met you around about 1985 at the International Congress of Nutrition in Brighton. And he said, no, I met you in 1981 with Professor John Waterloo at a meeting in Windsor. So that's how sharp and wise and reflective he is. So he must be eating something to getting so responsive for memory recall. Any more questions? Yes.
Well, I mean, without going into detail, I mean, if I were coming back into science, I think I'd go back to studying the gut microflora, because I think that's going to be a tremendous, it'll affect the gut hormone production. Also, we now know that I think my views on the role of adipose tissue have probably changed, because at the time we were studying it, even in Nancy's day, it wasn't known really that adipose tissue produced hormones, and that's going to be affected, I think, by the gut microflora. When I was, we haven't had time, obviously, to fill in my period at Reading, but I should say I was at what was then the National Institute for Dairy Research in Reading, part of the University of Reading. And one of my team there was a microbiologist, nutritionist, who had at her disposal germ-free notobiotic chambers in which we could study either a gut that was completely free of microorganisms, or one in which specific microorganisms had been introduced one by one. And I mean, I don't think we exploited that as much as we should. But if I were coming back, I would certainly be going back to look at gut microbiome.
Do you think will there be any ethnic differences?
Any ethnic difference in gut microbiome? I think that's pretty well known. It's pretty well documented. I think there are guys in US who are studying that. So they have a huge international consortia that actually taxonomically identifies bugs from Europe, from North America and Africa, and that's pretty well known.
Yeah, I mean, everybody's gut flora will be different.
Any more questions? Young man in the front, any questions from the journalistic perspective?
You just mentioned earlier how you started to look at obesity.
Yeah.
You were forecasting the rates of growth. Did you ever imagine it would be at the scale that we're seeing now, especially in some of the Southeast Asian countries?
No, I don't think so. How would one? It's quite amazing to see. Yeah. And well, Southeast Asian, but go to. Well, Britain is getting bad, but United States and America.
Well, I think we'll come to an end of this session, because as Mike had said, he's brought a few slides to show of cilia, and I think we'd love to see them. So firstly, a very big thank you to Mike for your wonderfully lucid presentation in terms of the life cycle, but more importantly show how the science is a connective process from the past, the present, to the future. So thank you once again, Mike. So Mike will get this out of the way, and then you can show us your slides.
Before we indulge in this, I should say that everything I've said to you today is based on my recollections of what happened many years ago. In other words, memories. Oh, I'm thinking, am I? Sorry. We now know, of course, from neuroscientists that memory is not some kind of photographic imprint that stays the same. It's changing all the time and being modified by the experiences that we receive every day. Oh, yeah, sorry. Memory can play us tricks, and it's altered all the time, and that has been, so what I'm asking you to do is to take everything I've said today with a pinch of salt, because it may not be true. And that has been very nicely written in a book called The Self-Illusion by Professor Bruce Hood. Bruce Hood is a professor of developmental psychology in the University of Bristol, and he's an expert on the development of the brain in the young, and in particular the development of the critical periods in which things have to happen in order for a development to occur later on. So I would recommend this very strongly if anybody wants to know about memory and how we see ourselves. Right. Okay. What Jay didn't say was when we retired in I'm getting tired. We stopped. My industrial career stopped in 1990, and my wife, who's sitting down there listening to me in utter boredom, I should think, and I decided that we would go freelance, and so we set up our own little consultative company. Anne was busy working for various scientific journals and proofreading and copy editing, and I was acting as a consultant to various companies around the world on nutritional matters. And then we decided that it was an age in which the PC was becoming available to everybody, and I think we tend to forget how much has happened. In 1990, the web was probably hardly with us, and so we decided to go freelance, and we decided that we could do that using a computer from anywhere we liked, and so this is where we ended up. And these are the Isles of Scilly, which, how many people in the audience have been to the UK? So a lot of you know the UK. Well, if you travel down to the far southwest, the long peninsula, and you get to the end of the mainland of the UK, and you go 50 kilometers into the Atlantic, and the next stop is Canada. And you come to this group of islands. There's about 150 islands of various shapes and sizes, but only 5 of them are inhabited. And the one we live on, unfortunately, is not shown on. But this is where we live. And it has a very nice climate because because we're surrounded by a sea, which the sea temperature doesn't change very much, so we don't have frost, Yesterday, Anne and I went to the Singapore Botanic Garden, and as we walked around the garden and saw plants from all over the world, we were amazed by how many the plants that we saw in the Botanic Garden are grown on our island. So this shows the fields on our little island, the hedgerows, and the agriculture of the islands used to be growing narcissus. And we were lucky enough to have elm trees on the island, which were destroyed on the mainland of the UK many years ago by a disease called Dutch elm disease. And this is so sensitive. Okay. This is the harbour of where we live. This is our house. This is our garden. So these are some of our exotic plants that we saw in the Singapore Botanic Garden yesterday, and it was amazing how many we found. Ah, right. Now, so these are the authors of the Lipid book. Oh, how do I stop it from changing? Is it automatically programmed to change? Ah. Okay. Right, so there's me. This is Professor Bob Michel, who is an expert in phosphoinositides and their signaling capabilities. The crosstalk between cells operates from a signaling system based on changes in inositol phospholipids. Myself, Dennis Murphy is an expert in fats and oils at University of Southwest. This is John Harwood, who did a lot of work with Paul Stump in California. He's Ran, and this is our man from the Wiley Company who produced the book. And since our retirement, our interests have gone from biochemistry to studying bats. Right, that's it. Okay. Okay, that was rather incoherent.
Very good, very good. Mike, so thanks once again from all of us for coming here, visiting us and sharing your very reflective life and science, and it's a very small token of your organization, something small. Thank you. We got some bento boxes outside. Just a minor request. Those who have registered, you will have a bento box for sure. Those who haven't, just hang around. You might get one as well. So thanks once again.